Hello, this is the intermediate track of Beam College 2023. And for the intermediate track, we will cover implementing a complex ML pipeline in Beam. This is session 1. So as it is session 1, first I would like to welcome you to the intermediate track of Beam College. This year, we are trying to focus on a specific use case, and we're showing you some of the many additions we've made to Beam to make ML inference work smoothly and cleanly on Beam. This is an area that we know is very popular these days, and so we strive to make ML inference easy to do on Beam with pre-made transforms that make this simple to take a model that you have and use it for inference at scale. I'm Kerry. These are two pictures I like to use to introduce myself. The left is me in a different corner of the room I'm in now when I'm working at home. I have two cats, and occasionally they will claw their way up to my shoulders and sit and accompany me. If you're lucky, they might show up in this video, though I've tried to discourage them as they're quite a bit larger than in that photo. The other picture is me with my 6 children during a very brief window when they were all exactly one head taller than the other. This was about a year ago, and I can't make the same beautiful stack anymore, but it's just something about the software engineer in me said, I have to arrange them in a strictly sorted ascending order. And for a little while, you could do that and still see everyone. But yeah, I work at Google. I work on Apache Beam, specializing in machine learning and GPU usage. And I live in the woods in North Carolina with my many children and pets. So in this session overall, we're going to be implementing a complex ML pipeline in Apache Beam. So we have 6 sessions. In this first session, I'll give you an introduction to ML in Beam and our 2 workhorse ML transforms, RunInference transform and the ModelHandler that encapsulates the details of a model or framework. In session 2, we'll go about choosing models and talk about how to adapt a model that you find somewhere else to a Beam pipeline. In session 3, we'll start to delve into a specific pipeline that we are going to develop as part of this intermediate session. We'll take a high-level view of the pipeline, the models involved, and what it's trying to accomplish. In sessions 4 and 5, we'll take a deep dive into the pipeline, demonstrating how we adapt each model to the pipeline and how we make sure we account for pre-processing, post-processing, and error handling for any of those pipelines. Finally, in the final session, session 6, we'll talk about expanding this complex pipeline, which uses small or toy models, into something that would look more like a real-life use case, solving a business problem. So the pipeline that we're going to be developing in this session at a high level is a pipeline that takes audio data as an input. In this case, these are telephone call transcripts from people calling in to a bank helpline. We'll first use a model to transform that audio clip into text. Once we have text, we will use a classifier to say what are the subjects these people are calling about. The calls from the classifier then take each separate category of text and send it to a different model. In theory, this could be an LLM that is fine-tuned for the particular use case, although for the purpose of this exercise, we'll actually use the same model for all different categories. Finally, we'll take the output of that model and we'll turn it back into voice. The idea is that our system here could take a call, find an appropriate response, and then give it back to the customer. Although, realistically, the latency involved might mean you would want that to be a callback rather than something where they have to wait on hold. The main tool we will use in this pipeline is our RunInference transform. Now, the RunInference transform is as I said, the workhorse, the main transform we use when we're doing machine learning in Beam in a pipeline. And the genesis of this RunInference transform was when we saw increasing usage of Beam for inference and saw that it involved a lot of heavy boilerplate code and a lot of repetitive code. So you might imagine that if you were writing your own inference do fun, it would look something like what we have on screen here. You would have to define your own setup code to do things like download and load the model into a GPU or a CPU. You would have to write your own processing code. And inside that processing code, you would have to be able to adapt whatever model call you have to the model you've loaded. You would have to do error handling. You would have to output metrics. You would have to do batching. Very likely, you'd have to do pre and post processing. This makes for a large and unwieldy transform, and it includes a lot of things that could be abstracted away for you. And indeed, that's what RunInference tries to do. With RunInference, you can use a ModelHandler class that takes care of all of the details of a particular modeling framework, such as TensorFlow, PyTorch, etc. And you can chain onto the ModelHandler and onto the RunInference call items like pre and post processing functions or error handling. RunInference itself will handle the batching, model loading, and other basic functionality. So RunInference is the transform, but the key element of RunInference is the ModelHandler. The ModelHandler actually has the code that understands how to deal with a particular framework and a particular model to get good inference results from your inputs. Model handlers have a naming convention like PyTorch Model Handler Tensor, where we begin with the framework, we allow that it is a model handler, and we say what kind of input type it expects. Mainly tensor or numpy are the two that we find most common. And often that type is omitted. If there's only one type of input, we only include it when we have usually a tensor version and a numpy version. We have model handlers already in the Apache Beam repository for a large number of different transform frameworks. We can pull models from TensorFlow Hub or HuggingFace directly, and we can also handle TensorFlow models, PyTorch, XGBoost, scikit-learn, TensorRT, and ONNX models. Because we handle ONNX models, you can compile a model from a framework we don't include to its ONNX format and run that. Of course, we also allow you, the user, to create your own custom model handler, although that's probably a little bit outside the scope of the intermediate section. We see that users who have experience with machine learning report that it's fairly easy to implement their own custom model handler if they need to. So what does the model handler code look like? This is a real example of using the HuggingFace pipeline model handler. HuggingFace pipelines are a way to make the orchestration of ML inference easy, even for a relatively complex model. So we have a HuggingFace pipeline model handler that allows you, the user, to take the HuggingFace pipeline's arguments and use them to call your model inside an Apache Beam pipeline. Here we can see that we need to provide what task, this is a normal pipeline argument, and which model hosted on HuggingFace we're going to use. We provide a batch size, and then we can provide specific pipeline arguments that are needed to run this specific pipeline. In this case, this is a speech to text model. And so we're going to have the length of video or a length of audio that it needs to break up, and also the device, the GPU, that we're going to be doing our inference on. And lastly, we say that this is a large model so that we know how to handle the loading of that model into the GPU correctly. So this is just an example, a high-level overview of what we're going to cover in this course, of the RunInference function, and the ModelHandler class that we use to implement different ML frameworks for inference. You can look at all the code here. This is in our open source Apache Beam repository under Python Apache Beam ML. The RunInference and ModelHandler base classes, if you're looking for those, are both in base.py in that directory. And we have numerous notebooks and examples showcasing our many model handlers in our GitHub repository as well under the examples inference directory. You can actually import those notebooks directly into Google Colab, and you can execute them locally on the Colab, including using a T4 GPU. So join me again in our next session where we discuss choosing models, and once you've chosen a model, how to actually adapt it to Beam. Thank you very much. Again, I'm Kerry, and it's been a pleasure. Thanks. See you again for session 2. Goodbye.